Hyperbolas. Hyperbolas are a set of two curves. Now, these curves have some specific properties. They share two foci, f1 and f2, and a center that is directly between both curves. The equation of a horizontal parabola is this: x minus h squared over a squared minus y minus k squared over b squared equals 1. Its center is hk. We have two vertices, v1 and v2, that have coordinates h minus ak and h plus ak. Our two foci have coordinates h minus ck and h plus ck, where c is a square root of a squared plus b squared. The endpoints of a conjugate axis. First, let's go ahead and talk about the transverse axis. Here, the transverse axis is horizontal. We can think of that as the axis that goes from one vertex to the other. A conjugate axis is vertical. The conjugate axis has endpoints h, k plus b, and h, k minus b. These two values are helpful in setting up and graphing the hyperbola. Remember, the hyperbola are these two curves. If I had the transverse axis and the conjugate axis, I can create a box and draw two lines that go through the vertices of that box, where these lines can help guide where the parabola is going to be graphed. If we have a vertical transverse axis, meaning a hyperbola is going to be opening upward and downward, the equation is y minus k squared over b squared minus x minus h squared over a squared equals 1. Here, the center is still hk. Our first vertex has coordinates h, k plus b, and our second vertex has coordinates h, k minus b. Our first foci has coordinates h, k plus c, and our second foci has coordinates h, k minus c, where c is equal to the square root of a squared plus b squared. The endpoints of the conjugate axis are h plus ak and h minus ak. Remember, the endpoints of the conjugate axis and the vertices, or the transverse axis, can be used to create two lines that can help guide us in graphing the hyperbola. And that is all.